Okay, today's my topic is gray water treatment by slanted soil system in terms of phytotoxicity. Okay, introduction. So, as you know, the domestic gray water is one of the promising reusable source. For example, in Japan, we use the 150 to 200 liter per day per person as a gray water and discharge it. Even in the Burkina Faso, where it's very dry condition, they use 20 liter per day per person. So this large amount becomes the big advantage. So in this study, we are considering this gray water to use in agriculture. In this case, advantage is first, required treatment performance is relatively lower because the first gray water concentration of the contaminants is very low compared to the black water. So it is very easy to treat. And second point is if we focus only on the irrigation reuse, the required water quality level is relatively lower. So it means that the treatment performance can be relatively lower. And second advantage is if we use the daily gray water to irrigation, it can provide it constantly. Especially in the dry area, situation is like this. So a stable water source, even if its amount is not so large, it is very appreciated by agriculture in arid and semi-arid zone. So we will apply the gray water to the irrigation water. Then one of the promising technology we are focusing on is slanted soil treatment system. This is very simple system, like this. Water comes here, then it passes through the slanted soil chamber. Soil is like this. Then it is drained to the next chamber and again pass through the soil chamber, then drain and pass and drain. So this uses only the gravity, so we don't need any energies. And also this system don't use any special material or special system, so it can be built by low cost. So this can be this will be the suitable for developing countries. Actually, we installed the slanted soil system in our pilot site in Burkina Faso. In this case, we modified this system like this. Here is the first chamber, and second chamber is a little bit longer than first chamber. Then people discharged water here, then water was treated and stored. Then people use this water to their vegetable garden. So, but one problem is that slanted soil system is originally developed to treat gray water to discharge into the natural environment. So, focus point was removal performance of suspended solid and organic matter and nutrients. Regarding these points in terms of the discharge, some study tested and checked in detail. But if we consider the agricultural reuse, we didn't have sufficient information. So we did some laboratory tests and in the pilot test. If we focus on this situation, what will be the key points? First, suspended solid and organic matter is also important in this situation, but it is important to avoid the clogging, not for the natural environment contamination. And pathogen is also important, but this is risk for human who is working in the agricultural activity. And regarding the nutrients, in the agricultural field, this is not problem. But another compound will be the problem. This is the phytotoxic material, such as detergent. So objective of this study is first, evaluate the performance of slanted soil system in terms of phytotoxicity. And second, give some information for design criteria of slanted soil system for irrigation reuse. Materials and method. We installed this experimental apparatus. We stacked the 4 chambers vertically. Then we input the gray water here, then treat it and drain and treat it. Then we took sample from each chamber's effluent. Our chamber has parallel 3 lines. We put the name for each lines, case 1, case 2, and case 3. These are independent. So for the case 1, we use the coarse soil in the first chamber and fine soil to second and third and fourth chamber. For the case 2, we used the middle size of the soil in the first chamber and second, third, fourth fine soil again. Regarding the case 3, we choose the little bit wider range sized soil, 1 millimeter to 9.5 millimeter. We prepared the artificial gray water. We made the shower water and laundry water artificially. The characteristics is like this. Then we mix the shower water and laundry water as an influent. Because in the real situation, gray water discharged not constantly, but the intermittent flow. For example, the morning, people's activity occurs and they use the water, and noon, evening. So assuming this situation, we also discharged the gray water 3 times in a day. Averaged hydraulic loading rate is about 5.2 cubic meter per square meter per day. This corresponds to the 1/10 scale of the Japanese family case, and also corresponds to the half scale of the family in Burkina Faso. We took the sample from each chambers, then we analyzed the basic items. And among these items, this is the important items to measure the quality: germination test and root length measurement. This is very simple method, and we don't need any special equipment. So just put the plant seeds, then put the sample water. We use the komatsuna plant. This is a very famous plant in Japan. Then after 1 day, we check how many seeds were germinated. Then again, 3 days later, we measured the root length as an indicator of the growth. Okay, results. First, the germination test. We observed no significant difference among 3 cases. And also, we observed no significant difference between the treated water and low-grade water and control. It means that there is no significant inhibition of the germination in this case. But regarding the root length, we also observed no significant difference among 3 cases. But we observed the clear inhibition in the low-grade water and treated water from first chamber and second chamber. But after third chamber and fourth chamber, we didn't observe the growth inhibition. Okay, discussions. Again, in this picture, our focus point is the clogging and pathogen risk and phytotoxicity. According to the former study, we know that if we use the fine soil, the E. coli and MS2 phage can be removed in 1 or 2 chambers. But the problem of the fine soil is that it is very easy to clog. 3 to 5 weeks later, they will clog. So one of the solutions is using the wider range sized soil. In this case, the performance of the pathogen removal will not decrease, but we can use it longer period. And regarding the phytotoxicity, the detergent is the most important parameter. Then, according to the previous study, we have already obtained this equation to estimate the detergent concentration. Then, by using this equation, we can estimate the last concentration in this experiment. In this experiment, we found the threshold between the second chamber and third chamber. Then, if we estimate the last concentration in this situation, the range is something here. This is almost corresponds to the already known threshold range of the growth inhibition. So it means that formula of LAS seems suitable to determine the required length of treatment. Okay, as a conclusion, this study evaluated treatment performance by slanted soil system in terms of phytotoxicity. According to our experiment, slanted soil system performed phytotoxicity reduction sufficiently. And results of the root length measurement fits well with the estimated last concentration and inhibition threshold. And therefore, last estimation formula seems suitable for determining the treatment length of the soil chamber. And in the practical situation, last measurement is a little bit difficult because it requires some special equipment. But for checking the performance, root length measurement seems very easy and reasonable. But germination rate seems not suitable to check slanted soil system. Okay, that's all. Thank you very much.